grab out some sort of colored pen for today. Sometimes it's nice, and I know sometimes maybe I use a few too many colors. Green is typically going to be review info, like pre-cal, algebra 2, algebra 1, whatever. Green is usually review. Blue is usually new, like notes. Red is usually something to do with examples. Black is, I don't know, just to give it a different color. But today might be helpful a different color because we're going to be pointing multiple times at why are we using the rule or how are we applying the rule, and I'll try to use my colors to kind of show that as well. I'm going to try to use, I think, blue. Blue would be like your extra color today, at least as far as my smartboard color. I mean, you could be using red or pink or purple or whatever. But I think colors might help us a little bit in internalizing what's going on. But yesterday we said, hey, this guy, we can derive with basic rules, but how do we derive it? We had to FOIL first. We had to multiply first. We had to change the product to be a sum or difference because we have a basic sum or difference rule. We don't have a basic product rule. And so therefore, we would have to go ahead and multiply it all out, then use the power rule, power rule, power rule, power rule. There we go. But then I also solved it. This is not your notes, but that's okay. Period 6 got a little bit farther. I don't know why. Period 6 notes came up. Maybe I didn't actually save these yesterday. It was one of those crash recovery thingamabobs. I'm like, hey, do you want to restore whatever was lost? And I'm like, sure, it was lost. Maybe I should recover it. Anyway, let's do file. Let's do save as. Let me go to, give me 1 sec. Or else we're going to be writing on random notes that aren't ours. Let me save it as period 6 because that is their notes. File save. Now let me go ahead and save as period 1 notes because I do like what I did yesterday. Guys, did you figure out what was extra from yesterday that we didn't do in class that's up here on the screen right now? What's extra? There's one little baby thing that's extra that we didn't touch yesterday. Boxes and triangles, I didn't get that fully written down, true. And then I don't think we wrote this down yesterday, did we? Okay, so what is this? We multiplied, or I multiplied, maybe you guys were just watching. I multiplied and did power rule. Done. What's this? I made the first a box, I made the second a triangle. Because whenever you do the product rule, you have a first and you have a second. Sometimes you have a third, and then we have to have all sorts of fun with that. But we have a first, we have a second. The product rule says, basically, I need to go and pair up. Rewriting one with the derivative of the other, plus is the sum of one function with the derivative of the other, and then one function, the derivative of the other. So I have, the way I do it is second d first plus first d second. It's a silly way of remembering it. Second d first plus first d second. Now, technically multiplication is commutative. So the order in like another lesson, another math teacher, another video, this could be switched. And addition is commutative. These could be switched. So some would say, and I think even CalcChat might do, first derivative of the second plus second derivative of the first. Like they might actually switch these terms. But there's this other thing called the quotient rule, and it's going to help if you get in the pattern of second d first and first d second. Second d first plus first d second is the product rule. Quotient rule has a minus, but we'll get to that in a second. So you could use F's and G's, function notation. You could use actual wordings of like, hey, the second one times the derivative of the first one plus the first one times the derivative of the second one. You could actually write this out. Or you could use little triangle box prime plus box triangle prime. It depends on your brain. I was saying a second ago, we're going to make one single forever card from this entire lesson that has both the product and the quotient rules. And I need you guys, and you can make a note of it starting now. When you write down the product and quotient rule, you must, on your forever card, pick 2 representations. I'm not going to force you on like a quiz to say like, hey, give me the box triangle definition of the product rule. No. If I ask you on a forever quiz about a product rule, I just need you to give me 1 or 2. So you get to choose which 2, after we go through examples, etc., which 2 seem to make more sense in your head. But it depends on who you are. Some kids love the box triangle thing. Some kids love the FG thing, and some kids just are like, whatever, I get the idea. Okay, so once again, 1 forever card, product and quotient rule, and how many representations do you have to put for each rule? 2. Okay, so let's check out what I did. I said, hey, there's another way to approach this derivative now that we've written down the product rule. Forever card number 11, I'm going to write forever 11A. Why am I saying forever 11A? Yeah, it's the first part of the card, but only 1 card is allowed to be used for this, okay? Product and quotient rule. I said there's another way to attack it. Instead of having to FOIL it all first, we can also use the product rule. Now, some of you guys are like, okay, fine, whatever. It's an alternate way of doing a derivative. I can just use basic rules. This is one product where we could have used basic rules, but there are tons of products where your hand is forced and there's absolutely no way to solve it. There is no way to go back to the basic. We have to use product rule. So I'm just using an example to start off that says, oh, we could have done basic rules, but we could have also done product rule to get the idea going in your head. So do you see how I chose a box, chose a triangle? Do you see how I chose a first and a second? Do you see how I chose an F and a G? Depends on which way works better in your head. And I went to the formula and I said, okay, in order to do this formula, I need box triangle prime. Wait a minute, that's not what I wrote. Oh, second D first, second D first. Who's the second one? Triangle. I did second, I just rewrote them. Triangle, triangle. D first. Wait a minute, D first. Box prime, I took the derivative. Oh, who's the derivative of 2x squared plus 1? 4x plus 0. Oh. Why do I want you guys to get really good at the basic rules? Because the basic rules are going to be incorporated in all the other rules you see in some way, shape, or form. So I have second, rewrite, D first, got him, plus first, rewrite, right? D second. What's the derivative of 3x minus 7? 3 minus 0, just 3. Now, are these two the same? Well, they should be. Are they? How can we know for sure? Wouldn't that be a 12x squared? Wouldn't that be a negative 28x? Wouldn't that be a 6x squared? Or wouldn't that be a 3? Does it match up, guys? 18x squared minus 28x plus 3. Dun, 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 dun. They're the same. Guess what? The multiple choice answer might look like this, or it might look like that. Your job is just to make it match. So let's go ahead and practice some more, huh? Here we go. So what if we have this guy? Ew, I don't like new rules. Let's FOIL it and then who wants to FOIL that? No one. No one wants to FOIL that, right? Write down the function f of x equals the polynomial 2 minus x minus 3x cubed times the binomial 7 plus x to the fifth. The trinomial 2 minus x minus 3x cubed times the binomial 7 plus x to the fifth. Now, if I were you with your colored pen, I would do one of three things. I would either name this guy first and this guy second, or I would name this guy f of x and name this guy g of x, or I would do a box and I would do a triangle. You guys choose one. Colored pen. Name it first, name the first one f, name the second one g, or put a box around the first and a triangle around the second. What are we trying to do? We're trying to avoid having to FOIL him and practice our product rule. So I want to see a raise of hands. How many of you guys just wrote down first, second? Who wrote down FG? Who wrote down box triangle? Okay. The majority was box triangle, FGs. I'll use your notation first. Then I'll finish with box triangle. So as we're trying to do the derivative, if I were you, I'd go back to your pencil now. As you're trying to do the derivative, f prime of x is equal to gf prime. Gf prime would be, rewrite g. F prime would be, now some of you are like, wait, I don't have the rule memorized. Okay, then in your color pen, why don't you go ahead and if you did the gf notation, why don't you just go ahead and write the rule? Gf prime plus fg prime. Write the rule and then try to fill it in up above. Or if you did the box triangle, you can do triangle box prime plus box triangle prime. I'm just going to be rattling off the rule because I know it so well. But you guys need to remind yourselves of what you're doing. So write one version of the rule, and then you're trying to fill it in up above. So the second, or the g, the first, and you take the derivative of. So guys, what is the derivative of 2 minus x minus 3x cubed? Negative 1, because it's 0 minus 1 minus 9x squared. Now some of you are just realizing, oh, like, I really need to get fast at the basic rules. The answer is yes. If you haven't gotten fast yet, it's okay. It's not like you've lost all hope. But yes, you really need to get good at the basic rules. So, second D first, GF prime, triangle box prime, plus first D second. F stays the same. G prime, box stays the same, triangle prime. First stays the same, second prime, whichever version you're using. What's the derivative of G? What's the derivative of triangle? What's the derivative of second? 5x to the 4th. Now, in essence, are you guys seeing in this rule that we really are getting one big binomial? Right? We're really having one big expression plus another big expression. So if there was ever to be a greatest common factor, if anything was ever to match, we would try to pull that out from the whole thing, kind of like grouping. If anything ever matched, we would pull it out to simplify our like having to combine like terms and distribute and all that jazz. But guys, is anything shared as far as what's inside these factors? No. So we can't do that. If there ever was, we would take it out because it'd make our lives so much easier. But since there's nothing that's shared, we're just going to go ahead to finish this puppy off. I mean, you could just box it and be done if it was a long answer and say, whew, that was hard, but I'm not going to simplify it and make it wrong. But if you're checking with an answer in the back of the book, it's going to have simplified all the way out, which means to check to make it match for a multiple choice, we're going to have to actually get everybody multiplied out. Nick, go ahead. I hear you.
How is it faster than just doing it in the first place?
Well, remember I'm giving you examples that are possible to do with basic rules first, just to illustrate. Soon we're going to get to ones that are impossible to do with basic rules, so we don't have an option. That's it. But yeah, as Nick just said, he's like, we're going to have to distribute anyway. I mean, one way is looking up binomial times binomial, whereas it's not so hard trinomial times monomial. It's like zoom, 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 as opposed to like zoom, 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 zoom. So in some ways, the multiplication is easier. In some ways. But you're right, you do kind of end up with the same mess. Guys, double check my math. I think it's -7 minus 63x squared minus x to the 5th minus 45, no, sorry, minus 9x to the 7th plus 10x to the 4th minus 5x to the 5th minus 15x to the 7th. Do we agree? Combining like terms, I see x to the 7th first. I have -9, -15, -24. X to the 7th, x to the 5th next, so -5 and -1, -6x to the 5th. Fourth next, only one of them, 10x to the 4th, x squared next, -6. And then my negative constant. AJ. Well, for polynomials, typically, just thinking about making it match, typically we go descending order by power. Yeah, typically we go descending order by power. You guys okay if I switch forward and you don't see the slide anymore? A, you have it in your notes. And B, hopefully some of you are starting to memorize it. Questions? Grace? I call it stick it to the man. Which, I guess, in a way, you're sticking it to me because I have to see whether you're right or not. However, ultimately, we're sticking it to the AP guys. Which could be, and the AP graders definitely are, both men and women, but you guys get the idea, right? Okay. So, Nick, do you see what I mean? Can I distribute x squared and sine and just do a basic rule? No. I can't distribute. I mean, it's sine and it's x squared, and they don't go together any more than they already are. And if you did do something to, it's illegal. But here's a problem. Do you guys see how this guy could technically be rewritten as 4 times x squared times sine of x? There's 3. Oh, is there really 3? Isn't 4 just a constant. Oh, so we have options. Here are our options. Now, don't go with your colored pen yet. Look at what I'm about to do. We could see this 4 as a constant multiple and just have him stay outside the product rule the whole time. But if he stays outside the product rule, do you guys realize he's going to have to come back in and a seal might die? What am I saying seal for? Seal is the distributive property. So if I leave the 4 out, do you see how some of you might forget to bring the 4 into both? So it's legal to leave the 4 out to deal with this guy first, second. But the 4 can very easily get lost. You know what's easier? Stick the 4 with somebody. That way he'll be dealt with in the rule. 4x squared, that's okay. I can take the derivative of that. That's no big deal. Sine of x, that's okay. I can take the derivative of that. No big deal. That's how I would do my first d second. Sorry, no. My first second. Pick your notation. Box triangle, first, second, FG. Pick your notation. With your color pen, pick your notation. How are you going to note the first, the second, the F, the G, the box, the triangle? You choose. And once you choose, I want you to go ahead and, with your pencil, write dy dx equals. And you're going to try and fill it in, but write the rule in your colored pen of which rule you're going to think. GF prime plus FG prime? Are you going to think second D first plus first D second? Are you going to think triangle box prime plus box triangle prime? Write a representation of the rule that you're going to use and then try to do it. Ready, set, and go. Actually, I did both of those last time. I'm going to do how I actually think about it. I literally always just think first and second. Either one's right. Sometimes the AP guys love to factor out GCF. Sometimes they totally don't touch it because they're like, we don't care. Sorry, make it match. They're both right. But the question is, did you get one of them? How are we doing? Vote. How many of you guys did the first, second thing? How many of you guys did the FG thing? How many of you guys did the box triangle thing? Okay, see, we're like almost evenly split. You're going to pick away and you're going to go with your brain. Okay? Does that mean that you're stuck in whatever way you're choosing in class? No, maybe try the different ones and see which one makes sense. Quotient rule time. Why? Because we've mastered the product rule? Not even close. Not even close. But we're going to get the other rule down first so that we have both rules. The rest of our forever card, quotient rule. You guys get it set up. I'm just going to fill in the rule. Is that okay? Okay. Make sure you put brackets around the g of x for the denominator. Bless you. I'm saying bottoms and tops because we have numerators and denominators. I said that totally backwards. Same bottoms and tops because we have denominators and numerators. Either way. Same bottoms and tops because we have numerators and denominators. Now pause. I'm going to go get a yellow box. You guys keep going. Sorry, I'm pausing. I'm going to get a yellow box. Forever card number 11B, right? We good? Okay. Forever card number 11B. It was fun in, what class was it in? Oh, it was you guys. Never mind. Never mind. Never mind. The 22B. I'm still stuck on that. It was just funny. I had small group last night for church. It just started back. We have like dinner first and then we hang out for Bible study. You'll see where it all comes together. I was saying section 22B. And it was chicken parm. And so the mom was like, chicken parm parm. And she kept on saying, come get your chicken parm parm. It was funny. She has little kids. Does anybody know what she was alluding to? Do you know the movie? Or is it too old for you guys? Yeah. Chitty bang thing. Chicken parm parm. It was just funny. 22B. Words are fun. Okay, bless you. I need you guys to make a quick note of something. I wasn't being totally honest. I mean, I didn't lie. I didn't mean to lie. I just didn't give the whole truth. When I told you guys you have to choose 2 representations because of the AP and because of the AP sometimes forcing your hand as far as notation, I need one of them. I'm sorry. One of them has to be the F and G one. You can write all 3 if you want. I don't care on your forever card. You can write all 3. But you can just choose 2, but one of them has to be the F and G one. I apologize for leaving that out earlier. Let's go back to the product rule. One of them has to be the F and G one. You can write all 3 if you can fit them. That's totally fine. But you get to choose one of the other creative variations, but one of them, I am sorry. Just believe me, I know what's coming. I should say, trust me, I know what's coming. One of the notations has to be the F and G one. Wait a minute, quotients. We totally dealt with quotients, didn't we? We totally dealt with them with basic rules. It wasn't a big deal. So hold on, even before I get to this page. Oh, you guys are all writing this example, aren't you? Oh, because you're amazing and you think ahead. I'm going to do a more basic example first. Because I keep on, and even my BC kids this year, I'm like, why? Why use the quotient rule? The basic rule is so much easier. Let's do a quick basic one for our example. That could be just basic, even though it could also be the quotient rule. Let's do something like f of x is equal to 5 over, oh, you guys can't do that one yet. Hold on. Something easy. Let's do 4x squared. Okay. Okay. Can we do this with basic rules? Yes. But what do we have to do to make it, or to do it with basic rules? Rewrite. Good. We have to rewrite first. So we're going to take the derivative for f prime of x. But we can't take the derivative until we rewrite, if we're using basic rules. So how could you rewrite that expression? Only x is to the -2. The 4 can be part of the coefficient. Does that make sense? Give me a thumbs up if it makes sense. Keeping you awake. Okay. So 5/4 x to the -2. What rule? Power rule. What comes down? Pause. Put your hand up and point to what comes down. Point and then bring it down. Okay. So therefore you get -5/2. You guys good? X to the? Write it down. -2 comes down. -2 over 4 is -1/2 times 5, -5. Should some of you write -2 times 4 and actually do the work? Yeah, maybe, for your brains. -2 minus 1, -2 in a number line, take away 1, moves it left 1, -3. A few of you guys with the negatives, you're still getting messed up. But is this the correct answer? And the answer is, yeah, it is. Negative 5 over 2x cubed. Are we okay with the rewrite back? But the question is, could the quotient rule work as well? As you guys learn the quotient rule and get better and better and better at it, yes, that's a you, just don't judge. Quotient rule. Some of you are going to use the quotient rule when a basic would have sufficed. It's just the way it goes. But I'm hoping by this example you can be like, wait, why use the quotient rule? It's just a basic. Rewrite, no big deal. Okay, quotient rule. How would we do it? Well, top, bottom. I'm going to write the rule that I'm going to use. When we go for the derivative, we could say that f prime of x is going to equal bottom d top minus top d bottom all over bottom squared. Oops, I just lost my function. Come back. Okay, so f prime of x is equal to bottom 4x squared d top derivative of 5 minus top 5 d bottom. What's the derivative of 4x squared? All over 4 squared squared. Who gets squared? The whole thing. That's why I'm having you guys put everything in parentheses. The whole thing gets squared. That's so much harder. I know. But guess how many of you later on this year are going to be solving that like this? Oh, so sad. Slows you down. That's going to be 0. That's going to be negative. That's going to be 16. Then you got to simplify the x and the x cubed. Maybe it will end up to be the same. Then you have to reduce and say, well, 8 goes into that one 2 times, 8 goes into that one 5 times. Think, what was easier? Oh, the basic rule. But you went for the quotient, not you. BC kids, I would say at least half of them would have gone for the quotient because they're so used to it. They're like, ooh, top, bottom, top, bottom, top, bottom. Just don't forget the basics. They're still valid sometimes, but why can't I use basics for that? Why not? Yeah, there's an F on top and a G on bottom. That's number 1. But do you guys remember that we've actually done with basic rules? We've actually done some work even with an F on top and a G on bottom. As you guys write down that example and start choosing, are you going to do box and triangle? Are you going to do first and second? Well, no, don't do that. Top and bottom. Are you going to do F and G? Label it. Write down the version of the formula that you're going to plug into. But I'm going to write up here, what's one with an F on top and a G on bottom? Now, I know it gets a little confusing because isn't the whole thing an F? We call this H. F, we're not saying this like, oh, there's a function on top, function on bottom. It gets a little messy with notation. But I'm going to write up something that we could have solved with a basic rule. And we'll talk about him in a second. They both have F's on top and G's on bottom, aka functions on top and functions on bottom, aka they're both rational functions. They're both rational functions, but that one could use basics, whereas this one could not. Can we talk about it now? Why could I go back to basics? And not there? Do you guys remember how we go back to basics on this guy? How do we rewrite? Multiply, we could do that. By what, Patricia? X to the negative 1. So some of you guys like rewriting this to be, like rewriting this to be 4x squared minus 3x plus 1 times x to the negative 1. Is that actually the same thing? Yes. And can we bring the x to the negative 1 in and combine because we have just x's raised to powers? It's valid. Others of you guys might have done something like 4x squared minus 3x plus 1. Division of a number is multiplication of its reciprocal. Some of you might like that better. And once again, an x squared over an x over an x, a 1 over x, x to the negative 1. Once again, you could go ahead and combine because we still have x's to powers. And maybe just a few of you have taken to heart my thing called where you can distribute the division. 4x squared over x, negative 3x over x, plus 1 over x, which is the same thing you get ultimately if you do any of these. But long story short, why is this able to go back to the basics? X. What are you dividing by over here? If I was to try, don't write this down. If I was to try to rewrite this, those methods, I would have x squared minus 1 times x squared plus 1 to the negative 1. How do I... I can't distribute that in. If I was to try to do heart method, A, it's ugly. And B, how do I simplify x squared over x squared plus 1? I don't, without killing a kitten and being horribly illegal. It's not even a pretty heart. No, it doesn't work. If I was to try to multiply by 1 over x squared plus 1, once again I'm stuck. So there's no other way besides quotient rule. Did I do this last time? I did do this last time. I'll do it with words this time. So f prime of x is equal to bottom d top minus top d bottom. Guys, is there a plus in the quotient rule at all? No. There is in the product, there's not in the quotient. So let's see how you guys plugged in, if you plugged in. Bottom, rewrite, with parentheses. With parentheses, bottom and top, numerator, denominators of fractions are always grouped. Bottom, d top, what's the derivative of the top? 2x. Minus top, rewrite. D bottom, what's the derivative of x squared plus 1? 2x. All over bottom, whole thing, squared. Now pause. We have options. We have options, but I'm trying to train you for what's to come. Couldn't we just distribute the negative and then combine like terms? Yeah. But couldn't we also say, hey, is there anybody in common? What's in common? Oh, so why don't we just pull out the 2x? And we have an x squared plus 1 minus an x squared minus 1. Wait, why did I keep the parentheses? I don't want to kill any seals. Not today. I need to distribute that to both, right? Then I can say an x squared minus an x squared, that cancels. A 1 plus 1, that's a 2. 2 times 2x is 4x. And my final answer is 4x all over x squared plus 1, quantity squared. Nothing's going to reduce. I can't factor that down anymore. It's a plus 1. That's an irreducible quadratic. Ooh, terminology from pre-cal. If I tried to factor that, it's going to be imaginary numbers, square roots of negative ones. Forget that. Leave it. Dun, 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 dun. Dun, dun. But do you see the difference between the ones that can't go basic and the ones that can? The nice thing about the quotient rule, though, is that it does keep everything in one nice big fraction. If I was, for this one, to go to basics, I'm going to have like a, well, eventually, what am I going to have? A 4, and then a 0, and then a minus 1 over x squared. Anyway, I might have to get common denominators if I use the basic rule to get a nice top-bottom fraction, whereas the quotient rule starts with a fraction, ends with a fraction, no common denominators necessary. Ready, set, I want you to bust out a quotient rule on your own. Choose FG, choose top, bottom, choose box, triangle. Write the formula and go. I'm going to use FG this time just because I haven't done that yet. But choose a notation, then go. 4x plus 1, quantity 4x plus 1 over x squared minus 5. 4x plus 1 over x squared minus 5. I'm not saying it out loud, so I get confused. Bottom D top minus top D bottom. Guys, was there anything shared that we got to pull out? No. So we're just going to have to distribute. Just don't kill any seals. There's a minus that needs to be distributed. Some of you stick it to the man might stop. Some of you might be like, but wait, what if something reduces? Good call. But sadly, I don't think anything much will. I would need to have a negative. That's an irreducible quadratic also. Dun, 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 dun. Do you think you at least have the idea of both rules? Okay, go practice tonight. Tomorrow we'll have more time to practice. But tonight, don't work on the speed per se. Work on memorizing product and quotient rules in forms that make sense to you, writing out your forever card, and then practice with homework getting started. Sound good? Whew! All right, cool kids. Happy Thursday. I'll see you later. Talk up.